Hi there, this is Mert Çalışkan from Atlassian. Today I'm going to talk about the Maven framework by touching its internals and laying down its fundamentals. Here's my agenda. First, I'll talk about the Maven fundamentals and how it eases the build. Then I'll define the POM, the project object model file. And Maven provides three build lifecycles which are default, clean, and site, and I'll detail those by giving their phases. And for dependency resolution, Maven provides a rule-based solution, so I'll define those rules as well. And for artifacts, Maven provides the scope management, and I'll define the details of the scope management by providing how they affect the class path. And in Maven ecosystem, everything is a plugin, so I'll define how the plugins are attached to the lifecycle. And I also talk about how to write your own custom plugin. For versioning and ranges, Maven provides a standard way of defining versions, and I'll also talk about those by defining the ranges. And for defining relationship between projects, Maven supports inheritance and aggregation. I'll also example those. And archetypes are Maven projects to create Maven projects. So I'll example those and give details on how to create projects by using archetype. So Maven is a project management tool from Apache Software Foundation, which provides a uniform build system. Actually, it all started when there was a need in the Apache Turbine project to create a common build system for its layers. So for Apache Turbine project, Jason Manziel, the creator of Maven, provided a comprehensive model for building software projects in a unified way. He favored convention over configuration, so you don't need to deal with the configurations like we did with the frameworks before, like Ant. And Maven provided a nice and clean dependency management where the artifacts are being fetched from public repositories. Maven has a plugin-based architecture. Actually, everything is a plugin in Maven. So Maven itself doesn't even know about code compilation, and there's a plugin for that, which is Maven-compiler-plugin. Maven is not just about building the project, it also provides a unified way to generate the documentation in your project. In order to install and run Maven, we need the JDK because we are going to compile code. And if you are using older versions of Java, like Java 5 or Java 6, you can use the Maven 3.1 or 3.2 versions. But starting from 3.3, Maven supports Java 7. So the latest available version of Maven is 3.6.1, and it can be downloaded from maven.apache.org, and it supports Java 7 and onwards. And I'm going to use IntelliJ for demonstration, and IntelliJ 2019.1, which is the latest version of IntelliJ IDEA, ships with an old version of Maven as bundled, which is 3.3.9. I also advise to update it as well. POM, the project object model file, is an XML file, and this is what makes your project a Maven project actually. It contains the definitions for the dependencies and the plugins attached to the build, and it also contains stuff like the project relationships, the list of team members, the licenses that the project contains, and the details of the source control management. So this is the brief overview of the POM. This is not the complete tag list. In order to access the complete tag list, you can download the XST file through the schema location given in the slides. The parent tag defines the parent-child relationship between projects. The group ID, artifact ID, and the version defines the coordinates of a project, and they are the unique identifier. The packaging defines the packaging style of the project. It could be a jar or a WAR file or an ER file. The modules defines the child modules that the project contains. Developers, contributors, SCM, the source control management, and licenses defines the metadata for the project. The build tag defines the plugins that will be used within the build, and the dependencies tag defines the dependencies that will be used within the project with their group ID, artifact ID, and the version. The GAV, group ID, artifact ID, and the version is the unique identifier for each project, and they're also called as the Maven coordinates. The group ID is the identifier for a collection of related modules, so you can reverse your domain name like com.oracle and then specify for a group or organization within your company like Code Online. And artifact ID is the unique identifier or the simple name of the module that you have, and we named our module as Maven app. The version is the identifier for the build number of the project, so it contains the major, minor, and incremental versions. So this is the simplest POM with the group ID, artifact ID, and the version. And when we execute the maven clean install command on the project, the codes will get compiled, the tests will run if any exist, the project will be packaged as a jar file and deployed to our local repository, which resides under the .m2 folder under user home. But how is that possible with 6 lines of XML? It's because Maven favors convention over configuration, and the whole configuration is coming from a super POM or Uber POM, as you call it. And it resides under the Maven model builder jar. So it defines the standard directory layout, so we don't need to define the source folder or the resource folder or the test classes folder or the target folder, and we don't need to define the repository definition for the central repository. If you want to see the merged, the effective version of your POM, you can just execute maven help colon effective-pom. So this is the extracted version of superform, which resides in the jar, and as you can see, this is the central repository definition, and it recurs itself for the plugin repository, and it also contains the definitions for the folders, like the directory, which points to the target folder, and output directory points to the compiled classes, and the final name is artifact ID dash version. And for source folders and test source folders, the source main Java and source test Java are defined in here. And the resources folder are also defined in the UberPOM. As you can see, the source main resources and the source test resources definitions reside in here. In order to download the Maven, you need to go to the maven.apache.org and then click the download. And the latest version is 3.6.1, and you can just download the binary by clicking the zip archive in here. To configure the downloaded Maven, you need to edit your bash profile if you are using Mac and add the m2 underscore home variable which points to the downloaded Maven. And you need to add the m2 home / bin in your path so that you can execute the Maven command. One other option is you can use SDKman to manage your development kits, and just go to sdkman.io. You can use SDKman to install Java, Maven, or whatever you prefer from the list. After installing SDKman, you can just execute it by SDK, and you can see the list of commands, and then execute like SDK list Maven to see the list of available Maven versions, and then you can just install it SDK install Maven. And you can just execute maven -version to see the installed Maven, which is 3.6.1. Process for building and distributing artifact is clearly defined in Maven, and Maven provides 3 lifecycles for that, which are default, clean, and site. The default lifecycle contains phases from validating your XML, the POM file, to deploying your artifact to a remote repository. The clean lifecycle clean the whole project files, all project files generated by a build. The site lifecycle generates the project's site documentation. And each lifecycle contains a list of phases, and each phase contains a list of calls. So lifecycle has a one-to-many relationship with phases, and phase has a one-to-many relationship with calls. So here is the default lifecycle and phases attached to it, which are validate, compile, test, integration test, verify, install, and deploy. Validate validates the pom.xml, compile the source and test sources. Test and integration test executes the tests. Verify checks for the integrity of your artifact. Install it to your local repository, and deploys to the remote repository. So to execute the default lifecycle, you can provide a phase with the Maven command, like Maven phase, or you can define it with Maven phase column goal, or you can use them together like Maven phase space phase column goal. And if I execute a Maven phase like Maven install, the phases before that, like validate, compile, test, integration test, and verify, will execute as well. So let's create a sample project Maven archetype. I'm pasting my command in here. I am using the generate goal of archetype plugin, and by providing group ID com.oracle.codeonline, artifact ID sample app, the version is 1.0, and the archetype artifact ID is Maven archetype quick start. And I'm just pressing enter. So I am providing yes, and the project created successfully. Let's change the directory sample app and see the contents of the project. So it creates a sample project with pom.xml and app.java and test class for it, app.testjava. And if I execute Maven install on my sample application, I will see that the artifact will be generated as jar file underneath the target folder, and the whole project will be bundled as jar by going through the phases from validate, compile, test until the install phase. So the default -bindings XML file, which resides under Maven -core jar, defines which plugins that will get executed according to the phases of the default lifecycle. And this also varies for the packaging like POM, jar, ER, var, rar, and Maven plugins. And in the code snippet, you can see that for the POM packaging, the install and deploy phases that will get executed. And for those phases, the plugins Maven install plugin and Maven deploy plugin will get executed with their goals, install and deploy respectively. So this is the content of the default -bindings XML file. And as you can see, the file defines the types with role hint and also defines the lifecycle with their ID like the default lifecycle, and lists the phases that will get executed by binding the plugins to those phases. So this is the POM packaging, this is the jar packaging, which is the default packaging type, and you can see the phases like process resources, compile, test, packaging, install, and you can also see the plugins that will get executed when you execute the default lifecycle with packaging type. And this is the EGB packaging. This is the Maven plugin packaging. This is the var packaging. This is the ER packaging. Finally, this is the rar packaging. So this is the most prominent features of Maven, the dependency and resolution mechanism. And this is actually where Maven can ease your development when you have hundreds of modules. And you can also depend on external frameworks, and Maven will fetch them from the public repositories easily. You only need to define the group ID, artifact ID, and version for your dependency. This could be either one of your modules or an external dependency, like in the example slf4j-api, and it will be fetched from the central repository by default. So transitive dependencies are at the heart of Maven dependency system, and it is introduced with Maven 2.0 version. It allows you to get the libraries that your own dependencies require, and it includes them automatically. So you don't need to take care of those dependencies explicitly, and there is no limit on the levels of the dependencies. So your module can depend on on an artifact, and that artifact could depend on another artifact, and so on. So the dependency exclusion mechanism is one of the most used features in the dependency management system. You may have a module X, and as in your module you can depend on Y, and suppose that you don't want to Z while you are fetching the Y. So you can define exclusion on Z by its group ID and artifact ID. So let's say that y releases itself and marks its dependency z as optional. This means that when x depends on y, will only depend on the y but not the z as transitive dependency. So this kills the transitive dependency on y, and x will be free of z when it fetches y. There are 6 scopes in Maven dependency management system, and they are compile, provided, runtime, test, system, and import. And they affect 3 class paths: the compile, test, and runtime class paths. The compile scope states that this artifact is needed for code compilation. The provided scope states that the artifact will be provided to the Maven project, and it affects the compile and test class paths. An example for the provided scope could be an artifact provided by the container at runtime. The runtime scope states that the artifact will be available at runtime, and it doesn't affect the compile class path, but it affects the test and runtime class paths. The test scope is only for compiling and running test sources, and it only affects the test class path. The system scope is much like provided scope, but with the system scope, the artifact will be provided as a file on the system path. Import scope is for the BOM, the bill of material artifacts, where they contain a list of dependencies to be imported. Dependencies can have types, and its default value is jar. So if you want to fetch a var file, for instance, you can define the dependency with the type var. Dependency management tag enables you to lock down the dependency versions to a given version. So this enables you to define dependencies in a parent POM, and the child POMs extending from this parent POM can inherit the dependency version from the parent POM. So only you need to define the dependency in the dependency management tag with group ID, artifact ID, and the version in the parent POM, and in the child POM you only need to define the group ID and the artifact ID. It is very easy to create Maven projects with IntelliJ IDEA. I'm just clicking Create New Project. And selecting Maven on the left hand side. Then I can use an archetype to create my project, but I'm just going to continue with a sample project. Then I'm going to create my project in work folder. And the module name is sample app, and the project will be created under the root folder in here. I am enabling the auto import. So this is my sample project. It's empty. It's my POM with the group ID, artifact ID, and version. On the right hand side, I can just open up the lifecycle and do a Maven clean install. And that's it. Within the target folder, my jar is created. So it's also possible to create new projects in IntelliJ IDEA by using the archetypes. I'm just selecting Create New Project, and in the Maven section, I'm selecting Create from Archetype, and going for Org Apache, Maven Archetypes, Maven Archetype Quick Start. There are versions for this plugin. I'm going to use the latest one. So I'm creating my project. enabling auto imports, and the project is now being created by the archetype plugin. As you can see, my app and test are generated. Beware that these archetypes are not up to date, so they are creating the content with old versions like JDK version or JLF version. I'm just selecting clean install and building my sample app. Running the tests, and that's it. I have my artifact built. Maven has a plugin-oriented ecosystem, and everything is a plugin in Maven. So Maven doesn't know about compiling code. There's a plugin for that called Maven Compiler plugin. And for building the artifact as a jar or a var, there are plugins as well. Maven jar plugin or Maven var plugin. So Maven plugins are also Maven projects with plugin.xml, which I'll get to that later. And each plugin can contain one or many modules. And modules are Maven old Java objects. And it has the same analogy with pojos, and each goal is a mojo in Maven. Plugin development is very easy by using annotations to define the modules, and I'll get to that in the next slide. So to recap, the default dash bindings XML file, which contains the default mappings, binds the plugins to the phases of the lifecycle according to the package type. So we have the default lifecycle, and default lifecycle contains the install phase, and for the install phase, the Maven install plugin gets executed with install goal. So Maven provides the infrastructure for creating your own plugin with annotations. First, you need to create a Maven project with packaging type maven-plugin, and then you need to add the Maven plugin which creates the plugin.xml. Then you can define your modules with the module annotation which resides under maven-plugin-annotations. And in the slides you can see the example of bundle module. So it's so easy to create a Maven plugin with IntelliJ IDEA by using the archetypes. So I'm going for Orc Apache Maven archetypes. Oops. And then selecting Maven archetype plugin. Enabling auto import, and my Maven plugin got generated full-flashed. So this is my generated Maven plugin, and the packaging type is Maven plugin, and I have the Maven plugin API and Maven plugin annotations defined as dependencies, and I have the Maven plugin in the plugin definitions, which will create the plugin.xml along with the help module. So this is my module, and this module touches a file and creates a file with the timestamp. As you can see, this is the source code, and my help module should be created once I do a clean install. I also test class for my module. In the target folder, under the generate resources, I can see my help module also got created. So my module is defined with the module annotation, and it is attached to the process resources phase. You could either assign your module to a phase, or you can just leave it by itself so that the user can invoke it by providing its goal. So versioning for modules and dependencies can be defined as major, minor, incremental separated with a dot, and it can be suffixed with build number or qualifier. So 131-snapshot or 131-12-snapshot are valid version numbers. So all versions with a qualifier are older than the same version. So 1.2-beta is an old version compared to 1.2. So versions can either be defined with ranges, and it could be either inclusive or exclusive. So the first version tag defines the version as 3.8 at least, and it should be lower than 4.12 at most. And the second tag defines the version as 3.8 as exact. So while using ranges on versions, you should be careful on not specifying broad ranges, like the version for the Spring Core, which is 5.5 at most, which means that when you build the project with this dependency, the Maven will try to fetch the whole versions starting from 1.0-RC1 to 5.0. Snapshot qualifier is a reserved one in Maven, and it implies that the project is still under development and it may change. By default, Maven checks for the snapshot dependencies from removed repositories daily, and you can change this by updating the update policy in your settings.xml as always, daily, by providing an interval, or never. And to update the snapshot versions and the whole dependencies, actually, you can just provide maven dash uppercase U to do a force update while building your project. So for this dependency graph, the question would be how Maven resolve versions. So we have a project with group ID A, artifact ID A, and version 1.0, and it has three dependencies for project D, project C, and project B. And project C has a dependency as well for project B with version 2.0. And the question would be here is, which B will Maven resolve? The first version, the 1.0 version, or the second one, the 2.0 version? And the second question here would be, which commons logging will Maven resolve? So there are three commons logging versions, and they are 1.0.4, 1.0.1, and 1.1.1. So the final graph for project A would be BCD with versions 1.0 and commons logging with version 1.0.4. So Maven applies two rules for resolving the dependencies. First, it fetches for the closest one, and secondly, it gets the sequential first at the same distance. To define relationship between projects, you can either define inheritance or aggregation between projects. And project inheritance allows you to define a parent project with group ID, artifact ID, and version, and child project can inherit from there by inheriting the group ID and the version. So this is feasible for defining a repository level or organization level POMs, so that you can group your dependencies and other properties or whatever you need in the parent project's POM, and that can be inherited throughout your organization. To see the merged version of your POM with the parent and the child, you can execute maven help column effective dash POM. So for my sample application, I can just execute maven help effective POM to see the merged version of the POM, which is quite long. Oops, all the way up. Or I can just click the pom.xml in IntelliJ IDEA and then go for Maven show effective pom, which opens up the merged version of the pom, the super pom. And you can do project aggregation with modules. All you need to do is define a module with the packaging pom, and you can define the modules underneath it, like project A, project B, and project C as seen on the code snippet. And here, if there's a dependency between the project A, project B, and project C as seen on the right hand side, Maven Reactor will decide which module to build first. So project C will build first, and then the project B, and then the project A. And if your build for the multi-module project failed for some reason, you can resume it with the -rf or --resume from by specifying the module that you want to. And if you want to build specific projects, you can just define it like -pl or --projects and give the name of the modules that you want to build. So Maven support profiles in order to create different builds out of the same pom. So you can differentiate your builds by using the same project object model, and you can define one of the profiles as active by setting the active by default to true. So in this example, I am creating a profile with slf4j and defining a dependency just for that with slf4j API. You can activate a profile by providing -p along with the profile name on the command line. And you can deactivate a profile by providing an exclamation remark before the profile name. It is possible to activate a profile according to the JDK version or according to the existence of an environment variable. So to activate a profile according to JDK version, you only need to define the version of the JDK, and you can do this with range as seen in the example. So there are other alternative ways to activate a profile, and one of them is according to the file existence. And you can define activation if the file is missing, as seen in the example. So the settings XML is the configuration file for Maven execution, and it should not be bundled with any project. There are two places to define the settings XML. One of them is under the Maven in conf folder, and the other one is under the local repository of the user, which is .m2 folder by default. So the contents of those files get merged, and if there's a collision on the configuration between those files, the one in the local repository overrides the one in Maven installation folder. And if you want to see the effective version of the merged version of the settings file, you can just execute help column effective -settings. So settings XML contains a good deal of configuration for Maven execution, and the local repository is one of them. By default, local repository is under userhome/.m2/repository folder, and you can configure it with this local repository tag if you need to change it. Interactive mode states that if Maven should attempt to interact with the user for getting input or not. And the use plugin registry tag defines if the plugin-register XML file will be used with the Maven execution or not. The plugin-register file defines the versions of the plugins that can be used with the Maven execution. So it is more like the dependency management tag, but for the plugins. With offline tag, you can tell Maven to execute offline, and this could be also possible by providing -uppercase O in the command line while executing Maven. So the rest of the configuration contains configuring servers with authentication mechanism, defining mirrors and proxies, defining profiles and active profiles, and plugin groups. So this is not the complete list. Please refer to the settings XST file to get the complete list of tags for configuring the settings XML file. Within the project object model, everything can be accessed as property references, and there's a common notation for that with dollar and curly braces. If you want to access the environment variables, just use the env prefix and then put the environment variable name. Every element in the project object model can be accessed as property references as well. Just use the project prefix and then use the tag that you want to use, like the version in this example. So the configuration in settings XML can also be accessed with property references. So with the settings prefix, we can just check if Maven execution is in offline mode or not. All properties accessible with system get properties call are also accessible with property references. You can just call them with java.home, host.name, user.home, etc. Also, if you have properties definition within your POM, you can access them with their name as property references, like the foo in the example. Debugging Maven is easy, and you can use Maven debug handy shell script to enable Java debug wire protocol on port 8000, and you can use it on the command line like Maven debug clean install, and this will enable the Java debug wire protocol. So it's also possible to debug a Maven build by attaching breakpoints to the modules. So I'm gonna show how to do that. First, I'm creating a debugging section with remotes, name debug on port 8000, and to set a breakpoint, I'm attaching the Maven install plugin into the class paths. Maven install plugin with version 2.4, which is the version that I'm using in this build. Then I am opening up the install module and setting breakpoints. Then I can execute Maven debug install on the terminal and then attaching my debugger. That's it. So I am debugging the Maven install plugin while building my sample application with Maven install commands. And if you want to debug a test executed by the Surefire plugin, you can just provide the Maven Surefire debug set as true. Thanks for listening. I just tried to scratch the surface of a framework that's been around over 15 years. And I hope you gained a firm understanding on the Maven fundamentals and how it works under the hood.